This is S. Lakshmanachari, Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering. So today I am going to explain how to interface LCD module with the 8051 microcontroller. So for that, first we need to open the Keel software. So click on Start and double click on the Keel Microvision 4. So the window will open like this. So first, for creating any new project, click on Project and select New Microvision Project. And on the desktop, create one file, one folder, and you can give some name, LCD. And I am giving the file name as LCD. And click on Save. And it asks the select device for target 1. So here, this window will show you all the vendors, all the different vendors of the manufacturers of the 8051 microcontroller. So you can choose any vendor or any manufacturer. So I am choosing NXP. So to find all the microcontrollers on that vendor, you have to drop down by clicking on plus. So here you can find all the microcontrollers are available. So I am selecting P89V51 or D2. So after selecting the device, click on OK. And it will ask the copy startup.a51 to project folder and add files to project. So this is the startup file. So this startup file is required when you are writing the programs in the C language. And when you are writing the program by using the assembly language, this startup code is not required. So this is only required when we are working with the embedded C language, embedded or general C language. So click on S to add the startup file. So when you click on S, the startup file will add it to your project. So click on this plus symbol to drop down the startup file. So here startup file is there. So now we need to write the program. So you can open the editor by using the file menu and then select the new. Otherwise, you can also directly open the editor by clicking on this symbol, this one, new. And also you can open by using the command Control N. So this is a program for interfacing of LCD, liquid crystal display, with the 8051 microcontroller. So here the first line is the header file, and for interfacing 3 control signals are required. So that are RS. So RS is the register selection. So that is connected to the P3.0. And next to RW, read or write. So this is connected to the P3.1 of the 8051 microcontroller. So P3.1 means first bit of the port 3. Similarly, enable. So enable, EN means enable. So this enable pin, it is connected to the P3.2. So these are the 3 control signals. So this RS, RW and EN, these 3 control signals are available on the LCD module. And next we will write the void LCD command, void LCD data and void delay. So delay is required to, we are providing the delay in between the characters. So after every character is displayed, it will show some delay. And then void main. So void main, within that we are writing the different commands. And for displaying, for transfer of data from the microcontroller to the LCD module, we are using a port 2. Okay, so this port 2, we are writing port 2 is assigned as the output 0x00. So 0 means it is a initial, the port 2 is initialized as the output port. And we are going to display a message IARE. And after that, after initialization of data, we need to initialize the LCD commands. LCD commands. So void LCD command. So P2 value. So P2 is the port. So through which we are sending the data. Okay. Next, void LCD data. Void LCD data. And next, void delay program. So this is a program. So once we have written the program, we need to save. So click on save symbol and give the file name, or directly click on this project. So directly that name will appear here, and give the extension. So we are writing the program in the C language. So I am taking the extension as the C, lcd.c. So in name of the file, don't give any spaces. So click on save. Okay, so now the program has been saved. So now click on the source group and right click on that and add existing files to source group 1. Now add this LCD file to your project. So that added file will shown here. So this is the file. After adding the file, close the window and right click on the target and select the options for target. So here we need to change the crystal oscillator frequency. So the crystal oscillator frequency for 8051 microcontroller is the 11.0592 megahertz. And after that, click on output tab and tick on the create hex file. So if you tick on this box, create hex file, it will generate a hex file. That means executable file. So that created hex file you can copy into your hardware. So that means you can copy into the microcontroller, 8051 microcontroller, and you can test the results on the hardware board. So once you have clicked on create hex file, click on OK. And now go to the project and build target. So once you have built the target, it will show any errors or warnings are there on the build output window. So this is a build output window. So here it is showing 0 errors and 0 warnings. That means there is no errors in the program. So now the program is build. So now we have to run the program. So for that, go to the so go to the project and build. So now the hex file is created. So you can see the hex file on you have created the folder. So go to the desktop and you have created a folder LCD. So open that folder. So here you can observe different files generated. So when you executed or when you created a project, different files will be generated. So C file, X file, LNP file, list file, microcontroller file, 3D object file. So like that, all the files you can observe here. So hex file. So this is a hex file. This file is generated. So this hex file we need to copy into the hardware, or you can dump this hex file into the hardware, or you can test this hex file by using the Proteus software also. So once the hex file is created, open the Proteus software. So this is the hardware connections. So this is the hardware connections of the LCD, interfacing of LCD module with the 8051. So this is a 8051 microcontroller and this is a LCD module. So in the LCD module, different terminals are there. So total the LCD module, it is having the 8 data lines. So that 8 data lines we are connecting to the port 2. Port 2. So that means data D0 terminal is connected to the port 2.0. Similarly, data terminal 1, D1 is connected to the port 2.1. So similar up to the D7. So total 8 data lines from the LCD module we are connecting to the 8 pins of the port 2 of 8051 microcontroller. And for this, for connecting 3 control signals. So the control signals are RS, RW, E. So these are the control signals. So RS we are connecting to the P3.0 and RW connected to the P3.1 and enable pin is connected to the P3.2. And here VCC, VSS. So VSS it is connected to the ground and VDD is connected to the plus 5 volts. Plus 5 volts. So this is a hardware connections. So now already we have created a hex file. So that hex file I am dumping into this hardware, dumping into this 8051 microcontroller. So for that, double click on the 8051 microcontroller. So a window will appear. So here it will show all the information related to the microcontroller. So clock frequency already it is there, 11.059 megahertz. So now choose the program file. So click on that and choose the LCD hex file and click on OK. So to run the program, so click on run. So in the bottom here it is a run. So click on that. So the data will be displayed here. So the message we have given IARE. So that IARE it is showing on the LCD screen. So in this way you can display any message on this LCD display. So in this way we can connect the LCD module with the 8051 microcontroller and we can show some information on that LCD display. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.